To optimize conduit usage and avoid code violations, several strategies can be employed. Firstly, prioritize critical circuits. Focus on running essential circuits such as lighting, power, and emergency circuits in the existing conduits. These circuits have high priority and must be accommodated to ensure the safety and functionality of the space. Secondly, utilize subpanels and branch junction boxes. Consider installing subpanels or branch junction boxes to distribute circuits and utilize the existing conduits more efficiently. This can reduce the number of wires running through each conduit and improve voltage drop. Thirdly, consider rating conductors. If the existing conduits are insufficient to accommodate the number of conductors required, consider rating the conductors. This involves using conductors with a low current carrying capacity, which allows for more conductors to be installed in the same conduit. However, ensure this aligns with applicable electrical codes. Fourthly, install auxiliary wiring compartments. Investigate the possibility of installing auxiliary wiring compartments, which are separate enclosures attached to the outside of the conduit. These compartments can house additional conductors without violating code requirements for conduit fill. Fifthly, use conduit expanders. Conduit expanders are devices that can be inserted into existing conduits to increase their capacity. This can provide additional space for wires without the need for new conduits. Sixthly, coordinate with an electrical engineer. Consult with an electrical engineer to review the design and determine if there are any alternative solutions to accommodate the required circuits using the existing conduits. They may have specialized knowledge or experience in finding creative solutions. Seventhly, request an inspection by the authority having jurisdiction (AHJ). Before completing the installation, request an inspection by the local authorizing having jurisdiction. This will ensure that the work meets code requirements and provide peace of mind. Eighthly, document your design. Keep detailed records of any modifications or deviations from the original design. This documentation will support your decisions and demonstrate that all reasonable steps to comply with the code were taken. Ninthly, communicate with the client. Inform the client about the limitations of the existing conduits and explain the steps you have taken to optimize their use. Seek their understanding and cooperation in prioritizing critical circuits and exploring alternative solutions. Tenthly, seek a third-party opinion. If significant challenges are encountered, consider seeking a third-party opinion from a qualified electrical consultant. They can provide an objective assessment and offer additional insights into options. When rating conductors, it's critical to adhere to National Electrical Code (NEC) Article 310.15, which provides guidelines for ampacity correction and adjustment factors. These factors account for the number of current carrying conductors in a conduit, as well as the ambient temperature. The NEC provides tables such as Table 310.15, B3, A, which outlines the allowable ampacities of insulated conductors rated up to and including 2000 volts, based on temperature rating and conductor size. When using subpanels, ensure proper overcurrent protection is provided of the feeder supplying the subpanel, as per NEC Article 240. This protection should be sized to protect the feeder conductors and the subpanel itself. Bonding and grounding are also crucial in subpanels, as detailed in NEC Article 250 to ensure a low impedance path for fault currents. When installing auxiliary wiring compartments, make sure they are listed and labeled for their intended use, in accordance with NEC Article 314. These compartments should be installed in a manner that does not compromise the integrity of the existing conduit system. Conduit fill is a critical consideration, and NEC Chapter 9, Table 1 provides the maximum percentage of conduit fill allowed for various conduit types and conductor combinations. Exceeding these fill limits can lead to overheating and insulation damage. Voltage drop calculations are essential to ensure that equipment receives the required voltage for proper operation. NEC Informational Note Number 2 to Section 210.19. 8.1 recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. These calculations should take into account the conductor size, length, and load current. In existing buildings, asbestos may be present in older conduit systems. If asbestos-containing materials are suspected, it's crucial to follow all applicable regulations for asbestos handling and removal, as outlined by the Environmental Protection Agency (EPA) and Occupational Safety and Health Administration (OSHA). Before making any modifications to the electrical system, conduct a thorough load calculation to determine the existing load and the additional load that will be added. This calculation should be performed in accordance with NEC Article 220 and will help determine if the existing service and feeders are adequate to handle the increased load. Consider using energy-efficient lighting and equipment to reduce the overall load on the electrical system. This can help minimize the need for additional circuits and make better use of the existing conduit capacity. LED lighting, for example, typically consumes significantly less energy than traditional incandescent or fluorescent lighting. If the existing conduits are rigid metal conduit, RNC, or intermediate metal conduit, IMC, they can be used as the equipment grounding conductor, provided that all fittings are properly tightened and listed for grounding purposes. However, if the conduits are PVC or other non-metallic materials, a separate equipment grounding conductor must be installed. Surge protection devices, SPDs, should be considered to protect sensitive electronic equipment from voltage surges. SPD should be installed at the service entrance and at any subpanels, in accordance with NEC Article 285. When working in occupied spaces, take extra precautions to minimize disruption to occupants. This may involve working during off-peak hours, using drop cloths to protect surfaces, and communicating clearly with occupants about the work being performed. If the existing conduits are buried underground, be sure to locate and identify all underground utilities before digging. This can prevent damage to other utilities and ensure the safety of workers. Call 811 before you dig. When pulling conductors through existing conduits, use a pulling lubricant to reduce friction and prevent damage to the insulation. Also, be careful not to exceed the pulling tension limits of the conductors, as this can damage them. Consider using a cable puller to assist with pulling conductors through long or difficult runs. All electrical work should be performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. This will help ensure that the work is done safely and correctly. Proper labeling of circuits and equipment is essential for future maintenance and troubleshooting. All circuits should be clearly labeled at the panel board, and all equipment should be labeled with its voltage, amperage, and other relevant information. Arc fault circuit interrupters of size are required in many areas of the home to protect against arc faults, which can cause fires. A size should be installed in accordance with NEC Section 210.12. Ground fault circuit interrupters, GFCIs, are required in wet locations such as bathrooms, kitchens, and outdoor areas to protect against electrical shock. GFCIs should be installed in accordance with NEC Section 210.8. If the existing conduits are damaged or corroded, they should be repaired or replaced. Damaged conduits can compromise the integrity of the electrical system and create a safety hazard. When making connections to existing conductors, use properly sized and listed connectors. Avoid using wire nuts or other methods that are not suitable for the application. Consider using insulated connectors to provide additional protection against electrical shock. Before energizing any new circuits, test them thoroughly to ensure that they are properly wired and grounded. Use a multimeter to verify voltage continuity and insulation resistance. Perform a ground impedance test to ensure that the grounding system is functioning properly. Document all test results and keep them on file. If the existing electrical system is old or outdated, it may be necessary to upgrade it to meet current code requirements. This may involve replacing the service panel, feeders, and branch circuits. A complete electrical system upgrade can improve safety, reliability, and energy efficiency. When upgrading an electrical system, consider using smart home technology to improve energy management and control. Smart home devices can be used to monitor energy consumption, control lighting and appliances, and automate tasks. Proper grounding and bonding are essential for electrical safety. The grounding system provides a low impedance path for fault currents, which helps to protect against electrical shock and equipment damage. The bonding system connects all metal parts of the electrical system together, which helps to equalize voltage and prevent ground loops. Surge arresters are devices that protect electrical equipment from voltage surges caused by lightning or other transient events. Surge arresters should be installed at the service entrance and at any subpanels. Power factor correction can improve the efficiency of an electrical system by reducing the amount of reactive power. Power factor correction capacitors can be installed at individual loads or at the service entrance. Harmonic mitigation can reduce the distortion of the voltage and current waveforms caused by nonlinear loads. Harmonic filters can be installed to mitigate harmonics. Emergency power systems provide backup power in the event of a power outage. Emergency power systems can be powered by generators, batteries, or uninterruptible power supplies, UPSs. Fire alarm systems are designed to detect and alert occupants to a fire. Fire alarm systems should be installed in accordance with the National Fire Alarm Code, NFPA 72. Security systems are designed to protect property from theft and vandalism. Security systems can include alarms, cameras, and access control systems. Communication systems are used to transmit information between different locations. Communication systems can include telephones, data networks, and public address systems. Low-voltage systems are used to power low-voltage equipment, such as lighting, control circuits, and security systems. Low-voltage systems should be installed in accordance with NEC Chapter 7. Renewable energy systems are used to generate electricity from renewable sources, such as solar, wind, and hydropower. Renewable energy systems should be installed in accordance with NEC Article 690. Energy storage systems are used to store energy for later use. Energy storage systems can be used to improve the reliability and efficiency of electrical systems. Electric vehicle charging stations are used to charge electric vehicles. Electric vehicle charging stations should be installed in accordance with NEC Article 625. Industrial control systems are used to control and automate industrial processes. Industrial control systems can include programmable logic controllers, PLCs, human-machine interfaces, HMIs, and motor drives. Healthcare facilities have unique electrical requirements to ensure the safety of patients and staff. Healthcare facilities should be designed and installed in accordance with NEC Article 517. Data centers have critical electrical requirements to ensure the reliability of their operations. Data centers should be designed and installed in accordance with industry best practices. Hazardous locations have unique electrical requirements to prevent explosions and fires. Hazardous locations should be designed and installed in accordance with NEC Articles 500 through 516. Remember to prioritize safety in all electrical work. Always de-energize circuits before working on them and use proper personal protective equipment, PPE. Follow all applicable codes and standards and consult with qualified professionals when needed. Continuous education is crucial for staying up to date with the latest electrical codes and technologies. Attend training courses, read industry publications, and participate in professional organizations. Proper planning and documentation are essential for successful electrical projects. Develop detailed plans, keep accurate records, and communicate effectively with all stakeholders. A thorough understanding of electrical theory is essential for designing and installing safe and reliable electrical systems. Study electrical principles, circuit analysis, and power system design. Use appropriate tools and equipment for electrical work. Ensure that all tools and equipment are in good working condition and properly calibrated. Maintain a clean and organized work environment. This will help to prevent accidents and improve efficiency. Proper waste disposal is important for environmental protection. Dispose of electrical waste in accordance with all applicable regulations. Be aware of the potential hazards associated with electrical work, such as electric shock, arc flash, and explosions. Take steps to mitigate these hazards. Work safely and responsibly. your actions can have a significant impact on the safety of yourself and others.